All right, guys, so this is section 11.3 foldable, and in section 11.3, we're talking about regular polygons, okay? We have had this word before, but we're just going to review it. So a regular polygon, make sure you know the definition, is a polygon with congruent sides and all congruent angles. Okay, so all the sides are the same and all the angles are the same. Okay, so one thing we know about all regular polygons is they can be inscribed in a circle. So this would be an inscribed polygon. And this was one of your vocabulary words in your circles vocab that you should know. And then anytime you have an inscribed polygon, this circle is called a circumscribed circle. Okay. All right, so those you should know. Okay. The rest we're going to kind of fill in the blank, and then we're going to explain what they are too. All right. So let's start up top here. So this B, when we inscribe this polygon in the circle, this B is called the center. Okay, it's basically the center of the circle. So the center of the inscribed polygons, circumscribed, circle. And because it's the center of a circle, we know it is equidistant to each vertex. Okay, so when I say it's equidistant to each vertex, that means from here to this vertex is the same as from here to this vertex, from here to this vertex. Okay, those are all equidistant because think of it as just the center of a circle. All right, so this entire thing right here is called a central angle. Okay, it's a central angle. So we get a central angle, it's just the angle formed by two consecutive, if you don't know what consecutive means, it's side by side, radii of an inscribed polygon. Okay. So this here would be a central angle. And if I draw this to this next vertex, this would be a central angle. Here to this vertex, this is a central angle. Here to this vertex, this is a central angle. And then once again, we have central angles. So this is a pentagon. It has 5 sides. We have 1, 2, 3, 4, 5 central angles. Okay, so if you have a hexagon, it has 6 sides. It would have 6 central angles. All right, next here, let's do this one up here. This is a radius. Okay, so if this is the center of a circle and we draw to the end of the circle, that's just a radius, okay? But it's also a part of this polygon as well. Okay, so the radius would be the radius of the inscribed polygon's circumscribed circle. All right, next, this right here, we're going to call this a side length. Okay, and this is a regular polygon, so that side length is going to be the same as this side length, which is going to be the same as this side length, which is going to be the same as this side length, which is going to be the same as this side length. Okay, so I'm going to write here, side length is the overall length of one side of the inscribed regular polygon. And remember, because it's a regular polygon, all those sides are the same. All right, last but not least, this here is called an apothem. A-P-O-T-H-E-M. Okay, and an apothem is the altitude. And an altitude is basically a line perpendicular from the center of the polygon to the side. And when we draw it, we need to know that it is the perpendicular bisector. Okay, so if I draw BD, one, this is a 90 degrees, this is 90 degrees, but two, AD is now congruent to DC. Okay, so that's the parts of a regular polygon. You should know each and every one of those.